Hi guys, I'm Mick Roper. I'm a software engineer who works for Reliably, and I'm here to have a little chat with you about how you can size a service level so that it provides a consistent user experience. This is an interesting topic, mainly because the natural sort of assumption and direction of engineers is to provide the most strict and contained and managed service level possible, and that isn't always the best option. So I'm going to have a few examples here and a few ideas, and I'd love to hear your thoughts on them. The thing that sort of pops up quite a lot is along the lines of this quote: "No one thinks about oxygen until it isn't there anymore." This is an interesting concept. Humans have an idea of a capability to not see things that are obvious. Instead, they tend to take them for granted. And if something performs consistently, it becomes normalized, uh, which means that it's very rarely reported on, it's very rarely talked about, it just is. However, if something starts to veer away from the normal, oftentimes in a negative way, it becomes very, very obvious. If it veers away from normal in a positive way, it's less obvious. People will rarely make a lot of noise that Facebook, for instance, is performing faster than it was 6 months ago. But if Facebook goes down for an hour, the whole world needs to know about it. So there's an interesting concept there that the perception of a user and their experience is very dependent upon what a normal experience for them normally is. An interesting thing about SLOs is that they implicitly set that user expectation. Going to the Facebook example, Facebook has no expectation that it will satisfy your request within 100 milliseconds, or that the news will even be honest. It's Facebook, so manage your expectations. So what a service level gives us is an opportunity to manage that expectation by not setting it too high, but also not setting it so low that they want to look elsewhere. This is an interesting point. It needs to be something that not only the user can accept, but you can maintain. There's no point being okay sometimes and bad the other times. Sort of driving that point home, it's better to be consistently okay than occasionally brilliant. This is an important point because we get told an awful lot in tech that we can scale infinitely, that we can use unlimited resources, that our users can be based around the world and work in any time zone, and we won't care. And it's not necessarily true. It's possible, for sure, but it all comes at a cost. Sometimes that cost is simple dollars. Other times that cost is the sheer size of an engineering team or the complexity of an application. And oftentimes it's not required. An awful lot of times you'll look at a system or even ways of working and you'll think, well, we don't really need the extra stage in our development lifecycle. We don't need this extra region in our deployment operations system. We don't need this extra complexity between the database and the business engine. When we're talking about these things, we must always look at them from the perspective of the user's experience. Whenever we add something new, it should help to build a consistent picture and not one that wildly swings. So if you bring a new product in there or a new piece of technology in there, that would mean that when you're in high saturation, it performs significantly worse. You've got to be careful there because that's really doing damage to your consistency. Basically said that this will work brilliantly until the moment where it's under pressure, at which point it will all fall over. This is a pretty common occurrence if you've got a transactional database, an old ACID safe database, where we value consistency over availability. It's a pretty common thing. Another obvious thing is that you need to be able to handle the perception of failures. If you're consistently good and a failure happens, then you're seen as only being occasionally good. You need to be able to manage that. So sometimes it's actually worth winding in your potentially brilliant application to make it just acceptable. A good example of this is the Chubby service at Google. Chubby is actually a service that's pointed out in the SRE handbook by O'Reilly, and it's an interesting one because it solves an awkward problem, at Google at least, which is how to manage distributed transactions. My general advice for distributed transactions is stay the hell away from them. No good can come from interfering with them, they just cause you trouble. In the case of Google, they sell data services, they sell them worldwide. Chubby is a requirement for them. That's pretty much the only case where you should touch them, really. But Chubby had an interesting little problem in that it was too successful. It was too good at what they did. It was very reliable and it was incredibly performant, which meant that no one at any point of these very complex systems that were depending upon Chubby ever built a system where they thought this might fail. They never built the expectation that what happens if Chubby isn't there anymore. And inevitably, when Chubby went sideways and the Google services were badly impacted, awkward questions are asked because the expectation now no longer meets the reality. The way that the Chubby guys got around this, the guys who managed the Chubby service, was to introduce error budgets and to effectively dial back the capabilities of the service. If it ever started to exceed its capability or its baseline, their version of OK, they would immediately inject faults and inject latency, and generally tone the whole thing down so it came back down to the baseline of OK. This had a couple of nice benefits. One, it made sure that the user expectation was well managed, but also it made sure that the guys who managed the Chubby service were able to understand the difference between excellent and OK and craft their application accordingly. That could mean winding down its capabilities, reducing the infrastructure load, reducing the effort of the engineers, and generally building a service that's more valuable on a case of return of investment. So what does this mean for anyone outside of Google? We want to avoid inconsistent service performance. And inconsistency is both ways. If you have an average latency, say, of 300 milliseconds, occasional 100 milliseconds are fine. Occasional 500 milliseconds might also be fine, but you've now got inconsistency. If you start having that happen often, I'd probably say anything beyond the 90th percentile, what you should actually look at doing is trying to bring that in line. That might mean spending engineering time trying to speed the service up where it's running slowly and understand why that's happening. But in cases where it runs fast, actively inject some latency. This actually builds on your baseline to make sure that you keep to a pretty standardized model. Same thing with errors. If you anticipate that over the course of a 24-hour period, 1% of requests will introduce errors, then for every hour they're going, look at the error rate. If there haven't been enough errors, then inject a few. Let them drop in there so that you've always got the errors that are available so that the consistency of the service is there. It'll help manage the user's expectations. So long as your error rate isn't so abominably high that the service becomes unusable, then that will work fine. What you're doing there basically is engineering a baseline that is acceptable to both you and your users. And the final bit is to inject some turbulence. And this could be done with something like the Chaos Toolkit, which actually some of my colleagues have reliably built. It's a very nice tool for this kind of thing. It's not quite designed for this, but it could be used. But certainly using tools that inject latency, having some mechanism that's able to dynamically understand the state of the overall application experience and decide what to do with it is valuable. These tools don't exist off the shelf, but they're not hard to build. So food for thought there. A piece of feedback I often get with this kind of thing is, yeah, but these things are all true, but it's not a reason not to do it. Yes, SLOs are contextual. What I mean by that is just me saying, take this in a 24-hour period. Some people will come back and say, well, our app is only used during office hours. That's fine, but you've still got a time window. You can still apply it to it, and it still has a service level. There's still a benefit in making that service level consistent. And ideally consistently good. We don't want consistently bad. My SLOs aren't static. No SLO is static. SLOs are always going to be dynamically affected, not only by what you're doing internally, but by what's happening externally. If a lot of users come on board, it's going to affect things. It's going to change the way the app works, and you might have to modify your objectives appropriately. By the same time, you might want to make some changes internally to embrace a new stack or work towards a new feature, which are going to also affect your objectives. So long as that change isn't dramatic, so that you're giving your users whiplash, it's going to work pretty well. And one that I've heard a few times as a reason not to do this is, my users want perfection. All users want perfection. What you tend to find is that the 80-20 rule is very, very applicable to a user. They'll get most of the value from 80% of the product, but make the most noise about the 20%. It's possible to give them an awful lot of value and then drip feed the 20% back in as it makes sense. As long as the experience is consistent, the users will generally enjoy it, so long as there's still value using your product. I'm assuming if you've got users, there's value to it. And that's me. It's an interesting topic, the idea of using a service level to manage a user experience. The two things don't often line up just quite that way, but the two are very closely related. So it is worth thinking about it. We spend quite a bit of time with this, thinking about this at Reliably. So if you'd like to have a chat with us, come and see the stuff we're working on, please do. You find us on GitHub, or you can reach me out on the email from the slide of this presentation. Thanks for listening, guys. Hope you have a nice day. Goodbye.